comes near, Eleanor Rigby. Okay, oh, the stream started. Here we are live.
Button. There we go.
There we go.
And the stream has begun.
Allocation, festivals, sessions. Oh, okay. We're gonna start with the sessions. Nice. It's a bit loud.
Okay, everyone, welcome to, gosh, I think it is day 14. It is day 14 of Handmade Hero, the show where we code an entire game from scratch, live on the internet, basically using only our wit and ingenuity, which are sometimes lacking. You know, it can happen, but we do the best we can. And we're making pretty good progress, I dare say. Today, what I want to talk about mostly is memory management, or at least the beginnings of a philosophy of memory management. We're obviously going to talk about it quite a bit throughout the entire stream as the need arises. But basically, that's what we're going to talk about today. If you have pre-ordered the game and are following along with the source code, this is day 14, so you want to unzip day 13 source, and that is what you will start with. That is what I am starting with today. So, let me tell you about why I think now is the time to start talking about memory management. One of the things that you will notice so far in the stream is we haven't done any memory management, and that is a good thing. So basically, if you look in here, this is actually kind of atypical nowadays. You know, most programs, most programming languages, most anything, you cannot really get into main without allocating a ton of memory. Crazy garbage collection, God knows what's going on. You know, you fire up a PHP program, which I was having to deal with over the weekend, in fact, for the forums. You fire up a PHP program, and God only knows how much memory is getting allocated and freed on every line. I mean, it's just crazy town, right? Memory allocation is just a willy-nilly thing these days. It's just full banana cakes. And so one of the things that I'd like to point out is we have done no memory management so far. Basically, all we did was we needed a sound buffer and we needed a bitmap buffer. So we just asked the operating system for 2 flat buffers. We never free them. They're just there forever and they're used. But our program is completely stable in the memory sense because of that. It just runs forever. You're never worried about there's no such thing as running out of memory in this program for the most part. If it starts at all, it's good to go, right? And that's a pretty interesting thing to think about for a second. Because technically...
I mean, now that he said that, I do allocate memory here. This could be just an array. Except this one. Because when the window size changes, size of the buffer changes as well. That could be fixed too. I mean, I could just fix the buffer and make it fit the screen. Does this count as an allocation? I mean, it kind of does. I don't really free it. This one definitely can just be an array. It's like fixed size, doesn't change at all. I would leave it right now as is. It's quite simple.
Anytime you do a memory allocation, you have introduced a failure point into your program, right? Memory is a limited resource, and basically every time you do a memory alloc, it could fail. And so if the result of that memory allocation was important to you, you basically have to handle that or just acknowledge the fact that your program better run on essentially an infinite memory device. Now, Fortunately, these days, a lot of times you are on what is effectively an infinite memory device for all intents and purposes. You probably won't be able to allocate enough memory to force Windows to run out of its own virtual backing store, but you certainly can hit circumstances where you will, start thrashing and stuff as the virtual memory starts paging and all these other sorts of things. There's all sorts of nastiness involved there, and also, what can I say? This is an old school programming stream, and in my mind, I kind of like to think about what it means to have programs that don't have those failure cases, that just aren't going to fail. If they start, they will run to completion and they will never fail. I like that idea. It's fun for me. And in case you haven't noticed, a lot of what this stream is about is making programming fun again for people who really like to kind of get in there and sort of do the real sort of work of like coding something meticulously and doing something interesting. And so to me,
I to say I am on that team. I am enjoying this quite a lot. Like diving into X11 and then Pulse Audio. Yeah, it's been a lot of fun. Frustrating sometimes, but fun mostly.
I really like thinking about things at a kind of different level than what most people like to think about. I tend to like to think about it as, can we just never do any memory allocation at all, right? Can we just never actually allocate any memory? And so one of the things that I guess might be slightly surprising to people as we go forwards here is I don't really anticipate us doing memory allocation. Basically what we are going to do is we are going to do sort of an old school flat partition where we just grab a chunk of memory at the beginning, we pre-decide how much space we're going to allow each thing to use, each subsystem to use, and then those subsystems are going to be written such that they must run in that space. So it is not a question of memory allocation down the road, it is just a question of they are hard written to never be able to go outside of a boundary that you give them. Does that make sense? I know that might sound a little odd for people who aren't used to it. People who are used to it, old school arcade programmers and stuff, are like, yeah, that's what we do. But obviously these days that's not typical. So anyway, I'm going to go that route, and so the techniques that I'll be showing you are going to be very different from what you're used to seeing in most, I would say, programming literature these days. But I think that's a good thing because, yeah, I like to show kind of different ways to do things. I'm not trying to tell you to do it this way, like I say on a lot of streams. I'm just telling you how I like to do it, and certainly almost every game that ships today doesn't do it this way. Most of them are allocation festivals, but
Jeez.
It's good to have different perspectives.
It is good.
So let's
to
jump
have
into
different
things here.
perspectives.
Why do I even think we need to start talking about memory allocation now? We have this whole program running. It essentially doesn't really do any memory allocation, doesn't ever free anything, and doesn't really need to allocate anything on any given frame. So why am I saying now is the time? Why do I think that's true? Well, it's because of this stuff right here. Basically what I did is to get this working while we were sort of playing around defining our platform API, is I said, well, we've got these local persists here, which remember is just static in C. It's something I've defined so we can see what it is when we grep for things, because static has 3 meanings at least in C, if not more, especially when you consider C++, there's even more meanings. It's just a keyword that's really overloaded. And so what I like to do is kind of get that down so that you can grep for it. So local persist just means that this is essentially a global variable. It's more or less like I put it out here. The only thing that's different is it's scoped just to this function. So it's kind of like a less obtrusive global variable, but it's still basically that. And I don't really like to have that sort of thing lying around. Certainly, I'm not going to be able to do that for all the stuff we need because that would be kind of a little bit absurd. I'm trying to think if what would happen if I just typed into C right here a local a persistent local variable that was like 4 gigabytes of memory. I have no idea what would happen there, but I don't suspect it would be good. So point being, if we want this game to have some stuff like, say, a large backing store for images that are getting loaded off disk or stuff, and we're talking about allocating like a gigabyte of memory to store stuff in or any of that sort of stuff, we actually need to get ourselves some memory here. And so I figured I might as well go get to that point now where we're actually storing our game state, because we do have some game state, blue offset, green offset, and tone hertz. So let's just pretend that that's real game state and not some test game state, and start to see where are we going to put that? How's that going to get stored? How's that going to work? Now, I'll show you basically what would normally happen in a normal scenario that is not being coded in the way that I'm advocating coding, because I like to show you kind of the other way first. So what would normally happen in a lot of circumstances is you would see something that looks a lot like this, let's say. Let's say game startup. So there might be a call like game startup that we call. It's got a game state that it returns, right? And what it's going to do is it's going to allocate one of these. So it's going to call an allocation function. So maybe that's malloc. Maybe that's in a lot of cases that would be, because it's be C++ code, it would call new, which allocates memory. If not told to do otherwise. Basically what would happen is it would new the game state, it would check here, hopefully, to see whether the game state actually got allocated properly. It would fill out some stuff in the game state, so it would do something like this, let's say. We'd have blue offset here, we'd have green offset here, and you'd have to imagine if this is a real game, which this will be in a couple months, we will have a lot of serious stuff going on in here. So you have to imagine if this were the real game already, there'd be a lot of stuff in here, not just these three things, but point being, it would start up and it would initialize anything that it needed to initialize to whatever it needed to initialize it to. Then at the end, it would return this game state structure, and that would basically be sort of like creating the game. It's like the constructor for the game. And if you were a C++ person, this would be a constructor for the game state object, for example. You could go many layers deep into this. And then later there'd be something like this. We'd have something called game shutdown probably. It would take the game state right in here, right? And then we would go ahead and we would delete the game state, right, like that, something like this. And then game update and render would take the game state as a pointer, like this, right? And then from then on, it would basically be fine because we would just use those things. Basically, we'd use the game state like this. So you can kind of see how I pulled that out there. You can see how I kind of got rid of those global variables by just pulling them out into a struct, basically. And that struct, we would define out here as like the game state thing, right? So we'd say something. Actually, I don't want to separate that to do from its thing there. So basically, we would have something that looks like this. And it would have our variables in there, our tone hertz, our green offset, and our blue offset, right? That's all that I'm talking about here. So that's it. That's like how that would normally go. We'll compile that there. And then this guy would have to pass it. So what I want you to see about this method is basically, and to extend it a little further, everything in the game would look like this. Whenever you wanted to do something, like you wanted to create a game asset, you would do something like this. You'd have game asset equals new game asset, some kind of a thing, right? Something like this. You'd pass maybe a file name to load it from. This would do some stuff. It would allocate that game asset, right? Oops, game assert. That's a nice typo. Game asset. It would allocate that here, this sort of thing. It would return it. Right, like this, and then you'd have a corresponding free call that would release it. So you're basically, your code would be littered with news and deletes, and this is very typical. I don't know what the status is of, say, Unreal Engine 4, but I remember, like, at least with Unreal Engine 3, it's like news and deletes are everywhere. There's all kinds of this sort of memory allocation going on. It's crazy town, and inside a given frame, there's tons of news and deletes, and all of those are technically failure points. And most of them probably wouldn't get handled properly. Maybe they would, maybe they wouldn't, but it's just kind of assumed for the most part that they aren't going to fail because either you've kind of, roughly how much memory you need, and you kind of know that you're running in that much memory or stuff like this, or they start to do things like they overload new to handle allocations in special ways, all these other sorts of things. So basically that's just typical, and it's typical even in high-end code. So I'm not trying to say that this is something not to do. I'm just going to say this is not what we're going to do. So that's basically what tends to happen in a lot of typical game code these days, right? So reasons why I don't love this. The first reason is because you got to have a strategy for the failure cases, right? Either you're going to have to handle it somehow. One way is basically you just say, all right, everywhere that we do a new or an alloc, we check for failure and we actually handle the failure propagating all the way out. That's difficult, right? That is tricky. in a lot of cases, because now you got all these paths that can both fail and succeed, and you got to know how each of them works. What happens if I didn't get a game asset and I needed to in this case? What happens if this particular system couldn't start up because of memory? Whatever. Do I panic? What do I do there? But you got to have a story. Another story might be, oh, well, we ran the game lots of times and we looked at how much it used, and we always make sure we get that much on startup, and then we use our own allocator that sub-allocates out of there, and we just know from having ran it multiple times that we know that it just doesn't overrun this much memory. We hope, and we just hope the player doesn't do something that we didn't think of. Who knows? But you got to have a story. There's some story. Sometimes the story, and there's plenty of games that ship, and this is the story. The story is we have no idea. The story is just we just don't know. It doesn't seem to run out of memory when we've tested it, so that's all we've got. And those are all not my favorite answers, so I don't really love that. That's one downside. But there's another downside that even people who think that I'm crazy about memory might agree with in a separate context. It has nothing to do with that at all. And basically what that is it adds another loop back to your platform abstraction. And one of the things that I was talking about before is like one of the reasons that I like doing the platform abstraction this way, and like I said, almost nobody does it this way, but basically the way where it's two data pipes in and out, and you're trying to basically minimize the cases where you ever do a round trip through the game. You pretty much just want the game to be a service to the platform, where the platform just says, I need the video frame, I need the audio. That's like what you're looking for, and it pushes down the input to it, just says, here's the input. So there isn't like any time when the platform calls the game calls the platform again, just to completely get rid of that round tripping. Because again, that round tripping is what creates complexity in terms of understanding how the platform and the game layer relate to each other, and it means that if you want to do some more advanced things, like say recording the entire session of a game and playing it back for debugging purposes, if you know that you have one defined input stream and one defined output stream kind of a thing, it's a lot easier to do that sort of thing, right? And so unfortunately, that argument is a lot weaker these days now that multi-core is such a thing. It becomes extremely difficult to do playback systems properly because of all the threading stuff, so it's the least of your worries, the thing I just said about. But in the old days when things were single-threaded, this was definitely a huge win in terms of playback. Not so much anymore, because you got a lot of other headaches you got to worry about in that situation. So, what's the alternative to this? What do I propose if I don't think this is a good idea? Well, what I'm going to do instead is I'm going to do exactly the same tack I took before and just say, well, if the game wants memory, then the game gets memory from the platform layer in a big old chunk at startup, and the game is responsible for doing everything else, right? Basically, I'm just going to say, you know what? We just pass in a big old thing here called game memory, and that's just a struct, right? And that struct is going to have basically stuff in it that allows us to allocate what we need, do our partitioning on the game side, and then all that's going to happen is the platform layer is going to call one, or it can call as many as it wants really, virtual allocs at startup to get our memory space set up, and then once it is...
I want to know, it's like if virtual alloc, what is it? Let me ask Cloud. What is virtual alloc? Is it similar to an arena? Serves virtual address space. Commits reserved pages to actual physical memory when needed. Operates at the page level. Can set memory protection attributes. There are some conceptual, okay, but they are different purposes. Virtual alloc is an OS level API. Yeah, interesting. What would virtual alloc look like intrinsic caps lock. Built-in page allocator. That looks very similar to... Ah, right, okay. Documentation. That's the only mention of it. I think a fixed buffer allocator seems even better. Are the allocations part of your cyclical pattern, such as a video game main loop? Can we free the ones at the end of the cycle? Well, to be fair, it doesn't need to be freed. I can just reuse it. Note that if an upper bound of memory can be established, then fixed buffer allocator can be used as a further optimization. Yeah, seems like a better use. Gotta look up standard. Do they have an example? Okay, and you provide a buffer. The only challenge with the frame is that it can change in size right now. To allow it to do here. Once frame size set, maybe, because this never changes. The sound buffer is always the same size. I just realized something. Resize. Yeah, freeze everything. What is this return? It returns a point to a U8. It's a weird pointer to a U8. Okay, no, it's a slice of pointers of U8 size pointers? Maybe. Not sure. Does the buffer always have to be a slice of U8? Hey Sensei. I don't know. I mean, that does sound like me. I do program in Go. I don't do any Android stuff. I mean, your name does sound familiar, so it's possible. Alright, anywho, I think the arena seems easier to use at this point. Not bad. How about you? Did you get your Android problem sorted? I mean, I could, everybody, yeah. The arena is much easier. I think I'll leave it as is. Really? I think that was like a long time ago, maybe a month or two. Don't even remember what the problem was.
Is set up, that's it. It just gets passed to the game. The game is responsible for sub-partitioning that memory, and it is responsible for ensuring that all of its systems always operate inside a fixed space, so they can be pre-partitioned at startup. And you know that if the game started up at all, it will run to completion. Period. And we'll be also seeing that I will take the same tack with disk I/O, which I realize is a little odd, but I'll be taking the same track with disk I/O. So the goal here is like there's 0 failure states in the game. The platform.
What? Huawei tablet bootloader being locked by a 16-digit code which isn't provided by Huawei anymore. Damn. Yeah. I think you're fucked. Like, what are you gonna do? I think I've seen this problem before. Somebody had a Samsung phone and it had the same problem. There was a pin on startup. Yeah, I think you might. Yeah. Yeah, I think I heard of that company. Yeah, I think your chances are quite slim, Sensei. But I mean, you never know. Maybe it's. Yeah, but I can't even be very positive. Can you use a different device? Or do they do it for all the devices? What are you even trying to do? I have no idea.
Layer obviously can have all kinds of failure states because the operating system is not built with a similar philosophy. The operating system is built poorly. It is Windows. It does not do a good job on any of the fronts that I'm talking about. And so once we get down to the platform layer, we can't create something that is reliable. That's true. But we certainly can create the game in such a way that it is 100% reliable, and that is what we will be striving for. We will definitely be looking as we go to hitting the highest benchmark we can in terms of making the game so that once it starts up, it does not fail. And if things like disk I/O fails, that just means there's sprites missing, but the game works, right? That's sort of what we're going for. And we'll sort of have a like gold, silver, bronze standard there, and we'll see kind of how high we can hit depending on the circumstance. Different games can hit that standard.
Those 2018 devices remove the option completely. Okay. I mean, I don't understand why, but maybe you have a reason.
At different levels depending on what they need to do. Basically, it has to do with space, but we'll get into that later. All right. Anyway, so basically all I want to do is I want to pass memory here, and I'm going to say a couple things about my memory. Basically, what I want to do is I want to sort of subdivide this memory into a few different partitions. Basically, I want to have scratch space, sort of space that is not really about storing the game, and then in theory could kind of go away at any given time. So it's kind of like space that is transient, and then permanent stuff. So basically stuff that stores the actual state of the game such that it definitely needs to persist as is from one frame to the next, because it's what holds sort of the game together. Right? And so basically what will happen here is I want to be able to store these things, the blue offset, the tone hertz, the green offset. Those are examples, right, of things that need to be stored in the permanent store. And so that's really all I have right now. And so basically what I've got is I guess I'm going to use an N64 here in case we ever want to be absolutely giant. So I'm going to say we have a UN64, which is essentially our permanent storage space, and then we've got a void star, which is our permanent storage, right? So all I'm doing here is I'm basically saying, well, I'm going to have some place to store. Wow, I'm a spelling genius tonight. Basically, I'm going to have some place to store things that have to persist from frame to frame, because that's what I want here. So all I'm going to do is I'm going to basically say, well, that game state thing that I had, right, that I defined before. Oh, did I just go ahead and delete that? I'm an idiot. That's not good at all. I wanted to keep that. I just wanted to move it. I didn't want to delete it. There we go. So anyway, let's get that back there. Game memory. There we are. So basically what I want to do is I'm going to take this game state here, right? And I'm just going to put that inside the game memory. Now I can put that here. I don't know if this doesn't really need to be in the stuff that defines the platform. So I'm just going to separate that out for now. We'll see where I want to live later, because this is not something that the Win32 layer needs to know about. So I'll think about it a little differently. But point being, this guy is going to come in here, and basically all I'm going to do is I'm going to say that my game state, right, whatever this game state is, that's just going to equal for now. I'm just going to go ahead and cold cast straight to the actual memory that I've got for my permanent store, right? My permanent storage right there. And then what I'm going to do is I'm going to basically introduce a notion here. And that notion is essentially that the game memory will have some concept of whether or not this is the first time around. Because obviously there's initialization that has to be done, that initialization that was going to have a call before that did the round trip alloc. I still want to do the initialization. I just don't want the round tripping. So I'm going to say for now, I'm going to say is initialized, and basically that's going to be false the first time through and true every time thereafter. So basically what I'm going to do here is I'm going to say if the memory is initialized, I should say if not, then I am going to go ahead and initialize it. I'm going to go ahead here and say that the game state, tone hertz, are 256, and then the other guys, let's see, green offset equals 0, game state blue offset equals 0, and that's really all I needed to do, right? So now we've gotten rid of our local persists, and those are in there. So now all I need to do is I actually need to pass this this memory out to the game. So I'm going to call that game memory. I'm going to go ahead and say game memory, and then I've got to actually do those allocations here. to actually get it something that it can use. So where's my virtual alloc? I've got it in here somewhere. There's for the there we go. There's the one for sound. So I'm going to still do separate virtual allocs for now, even though in the future we may well pool those guys together, because that's something I wanted to do. All right, so the game memory, I'm going to wipe that to 0 first. Then I'm going to say the permanent storage size. I don't know how big the permanent storage size for our game is. These are going to be constants we're going to tune. But I'm going to say something like 64 megabytes maybe. I don't know. Let's pretend that it's going to be 64 megabytes. Just for now. We'll see how much we actually need later. And then I'm going to say that the permanent storage, right, like this, is going to equal another one of these nice virtual allocs here. And that's going to be however much I just said the storage size was. So there it is. We're going to mem commit that because we're going to use it. And then all I'm going to do is I'm going to go up in here into this guy, and I'm going to define a couple more macros for me here. These are ones I just like to hold around, basically kilobytes, megabytes, and gigabytes, just in case you ever want to use those. So basically whatever you pass in here, whatever the value is going to be the value, right, times 1024. Does that make sense? Basically, like, so if you said 4 kilobytes, you're going to multiply by 1024. And then basically, each one of these is just going to be the exact same thing. You could think about it as doing it this way if you wanted to. It's a macro, so it'll expand, so it's kind of free for us to do this. We don't have to worry about any kind of penalty there or anything like that. So we're basically just going to say, oops, megabytes value times 1024. So basically what you can see is that's just a shorthand. So if I wanted to allocate 64 gigabytes for some reason, I could do that. But I'm just going to do that, right? Does that make sense? Hopefully that makes some sense. So what we need to do here is just pass the pointer, and then I think that's good to go. Okay, so basically what we're going to do is we have the is initialized thing here. It will be set to 0 by default first time through. And of course, if I were just to run it now, is initialized will never get set to true. Now the question is, who sets is initialized to true? Is it the game or is it the platform layer? For the moment, I'm going to say, and I'm not 100% comfortable with this decision, but I'm going to say that it's the game. The reason I'm going to say that is because it's one less thing the platform layer has to do, and the game is always going to do it here. So I'm going to just say that it sets to initialize true here, but I'm going to say this may be more appropriate to do in the platform layer, and we'll think about it later if it ever comes up, something to think about. We will do that. And so now, in theory, we should be able to step through here and see what goes on. Now, basically what happens is when we get to that point in the code, I keep zooming right past it, people. There we go. So we come in here, right, and we've got our game memory, and it is just initialized to 0. We then sticks how much we want to put on the how much actual memory we want there, so that's 64 megabytes, which is exactly what we wanted. We're then going to do our virtual alloc and hope to get that space. It looks like we did, so we're all happy there. And basically what I want to do, I forgot to do this, and we might as well do this now. I want to actually also check those, because obviously there's going to be another if here somewhere, which is basically like, hey, if the samples, and the game memory are both valid, then do the game, right? And we're not really going to do it quite like that at the end of the day, but it's sort of the same thing. So basically, if we can't get the memory, we're not going to run, because if we can't allocate the memory we need to run, well, there's not going to be much of a game if it can't store anything, right? So we come through here, and then we're going to go ahead, and the first time through, when we call this guy game update and render, we step in there, we take a look, we get back the game state, and that's just set to point to that first bit of memory there. And then we go ahead and do the initialization of it. There it is. And then we set the memory initialized to true. So the next time through here, when we come back through again, we won't initialize it. We'll just skip right over it. So off we go. So basically what's going to happen is we should expect to see everything tracked. It is tracked. That's all good. Everyone's happy. At least I'm happy. And sometimes it's about making me happy. Most of the time it's about making the viewers happy. Honestly, I'm here for you guys. But sometimes, you know, you got to make yourself happy as well. If you're not happy, how are you making your stream happy? That's the way I like to think about it. We should all be happy together, ideally. If someone has to be miserable, it might as well be me rather than you. But if we can all be happy, that's the best of both worlds. So, the next thing I wanted to ask about, basically,
I don't understand why. What is it used for? Is it to save game state? See game update. Currently, it's just saved in the sound buffer. Interesting. Okay, I see what he means. Okay.
because I know this is a little ridiculous. I don't pretend that it isn't, but I'm just going to go ahead and say, I'm going to go ahead and I'm just gonna go out on a limb here. I'm gonna go out on a limb and say, what if Santa Claus is sort of real? You know, I'm one of those people who didn't believe in Santa Claus even when they were little. Basically, thought it was all big old lie. It was true. It turned out that I was right about that. It's unfortunate, but what if I was actually wrong and Santa Claus is real and we can get everything we want for Christmas? The thing I want to basically know is this. Memory allocated by this function is automatically initialized to 0. Do you see what that says? Now, that is like the sleigh with the reindeer and the blinking red nose. The only thing that's not in the sleigh yet is the presents, but we're going to get those too, because what that says to me is basically the thing that I always ask for. The thing that I was like, I like having initialization be clear to 0. So that basically just like as much as possible, you don't do any initialization, you just clear to 0 and things are initialized. Well, how happy am I? Because basically that's exactly what happened here. I don't even need to do those two things, because now I'm just guaranteed that basically the permanent storage is always going to be cleared to 0 on this platform and probably any other platform that has security. And it's not that expensive to clear 64 megabytes to 0. It sounds like a lot, but it's instant at startup. You don't even notice it. I mean, you didn't see it happen, right? Neither did I. So basically, what that means is I can just go ahead and define that I want this for Christmas. I can basically just say permanent storage is basically required to be cleared to 0 at startup. If the platform doesn't already do that, then we'll write the code to do it in that particular platform layer. So that's good. That is what we want to see. So that's present 1 for Christmas, but I'm sorry. That's I guess that's I say I was in my metaphor that was the reindeer. I want the sleigh with the presents now. The sleigh with the presents is this guy right here. So basically, that 0 is a sack of it's a Santa Claus's sack ready to be filled with presents. And I apologize for the young children on the stream for using the word sack like that, but I meant it in a good way, something that carries presents. Basically, what we're talking about here is this parameter that we have been ignoring, this LP address. Basically, if you pass 0 to LP address, what that means is that the address you're going to get back from Virtual Alec is going to be whatever the operating system wants to give you. And that is fine for most purposes. We don't care where the sound output went. We don't care where the bitmap is. But I'm going to argue for the moment that we actually do perhaps care where the game memory is. And so we're going to do a permanent storage. I said before as well we were going to do a transient storage. Remember, I said that I wanted to do a transient storage size as well. Basically something that's kind of just like ephemeral. It's used for doing work, but it doesn't have to persist necessarily, those sorts of things. I'm going to say that for those things, we may well want to actually have a way to sort of, to make these be at fixed locations in memory when we're running on our machine. Now, in the wild, it would be foolish of us to expect that we can always ensure that no matter what platform we're ever running on in the future, that we can mandate the location of an allocation. If the world worked the way I wanted it to, you absolutely would be able to do that. As far as I'm concerned, that should have just been locked down. Like, all addressing should have been totally locked so that you actually say just where you want your stuff, and that's it. Unfortunately, I do not rule the world, or maybe you think that's fortunately, because everyone would have to eat tonkatsu and lobster all day or stuff like this. But ignoring things like that are a little weird, and the almond milk situation that would probably result, that I think would have been a much better way to go, and programming would have gotten a lot simpler, and there would have been a lot of things we could do that would be a lot more powerful. But short of getting that present down the chimney this Christmas, we can get something else, and that something else is on our machine. When we run, we can have the same memory location every time we run. That means two things. One, it means all of our pointers will be the same every run until we actually change code so that they, are allocating more stuff or something like this. And that really helps for debugging things, because it basically means that if you look at a pointer in one run of the program, you can know that it's going to be that same pointer, assuming you do a deterministic set of steps in the next run of the program. Whereas normally with Windows, where it does its address randomization stuff for security, that's not going to be true. If we were just allocating off the heap, it'd be wherever it was, and I assume virtual alloc also returns random addresses as well. I don't actually know because we haven't tested that, but I assume that they're going to be different every time. In fact, I think we may have seen them be different every time we step through before. I don't know. Doesn't matter. Point being, we want to lock that down and make sure that we know that we're always in the same place for a number of reasons. Debugging is one of them. Other things will come later where it's like, hey, did you see how I did that? Well, that was because of this. So basically what I'm going to say is that basically our transient storage, let's say, is going to be bigger than that. Our transient storage, I think on the PC, realistically speaking, I think we want at least 2 gigabytes. I mean, because basically PCs have a ton of memory these days, and we're going to want to use it. On Win32, I don't think anyone's going to be running this game in less than 2 gigabytes on the bigger side. Now we'll shrink that. We'll basically make that shrink down on lower platforms, obviously, but when we're talking about running the big high-res graphics, we're going to want that to be big. So certainly during development, 2 gigs, 4 gigs, let's say 4 gigs, just so it pushes us up to the oops, that's no good. That's 4 terabytes. So 4 gigs would be good because that actually gets us up to full 64-bit address range, so just make sure we didn't screw anything up with our pointers. So let's try this and just see, and then later we'll make a low-profile version where these things are much smaller. So let's try that. Let's go ahead and try that and see what we can do there, and then I'm gonna specify these memory allocation locations as well. All right, so in Handmade here, I'm gonna go ahead and make another one of these. This is gonna be basically, I'm gonna replace permanent with transient. That's about the only thing that's gonna happen.
I forgot what the permanent storage type was. Okay, it's just a UN64. No, what's the storage? Is it a struct? Can't remember.
And since we can, we'll just require it to be cleared to 0 again. Why not? Let's just see what happens. I mean, if it's going to do it, it's going to do it. I assume, too, I should mention, I mean, I don't know, I'm guessing. Yeah, so did that just work? No, it didn't work. That did not allow me to, why not, what? Why not? Why can't I allocate the memory? So it did not like it that large, apparently. Oh. No. Awesome. That's fantastic. Well, I guess you should just expect these sorts of things. So what happened there was kind of, and it's good that this happened some point on the stream so I can explain it. This is annoying. So basically what happened there is we wrapped. The exact thing I just said to make sure that we don't have any bugs is exactly what we did have. The problem here is that C has decided, in its infinitesimal wisdom, that it wants to do this in 32 bits, this computation. So when I said 4 gigabytes, it proceeded to take 1024 and multiply it by 1024 and multiply it by 1024 and multiply it by 4 gigabytes, which perfectly gets to 4 gigabytes, which perfectly gets to the 4 billion number that wraps a uint32 around to 0. Now I wanted it to do it in 64-bit, which I can't actually tell it to do in any other way. So basically what I have to do here is I have to give it something I have to sort of poison the pot, if you will, because the way C does things is it will promote numbers up to higher bit depths if something in the expression is requiring that, right? So what I can do is try to convince it that I need this to be done in 64-bit by saying that that 4 is really a 64-bit 4, please. And then when I come in here, in theory, I will get, yeah, there we go. I'll get the actual number that I wanted. That is really annoying. I hate stuff like that. It doesn't make any sense. I don't like the way C does that sort of stuff. I believe that's technically called integral promotion, and you can read more about that nonsense. Integral promotion. Let's take a look here. Come on, hello. There we go. So basically this old ridiculousness, this is kind of the annoying stuff where it's just like, and I don't know if this is actually, yeah, it might not be all this. Point being, I'm not going to belabor it because, first of all, I don't even know what all the rules are. Like, at one point I probably read them, but I don't even know. Like, if you gave me an expression with something complicated in it, I wouldn't necessarily know when it decided to promote things to unsigned or signed and bigger and smaller and all this other stuff. Basically, it's just really annoying. It's one of those things where C has all these rules. It should have just been explicit or had some way of saying, you know, if it's all constants, then it just produces the resulting constant, and if it's not, that does something else. I don't know. Language designers should have worked something out better. Hopefully when John does his language, there'll be something awesome in there. I don't know. But point being, that's what we hit. Now that we've taken care of that, it should be fine. Yeah, there we go. And so like you see, there's no penalty there for clearing to 0, really, because what I believe happens, and like I was saying before, I don't know this for sure, but what I believe happens is I don't even know if Windows ever bothers to actually clear all that memory right then. I think what it might do is just mark it as needing to be cleared, and then when we actually go to access the page the first time, it does the clear right there. I don't know. I don't know what it does. I don't care. It's fine with me. As long as we don't see any kind of performance weirdness from it, we should be fine. As soon as we start using the memory, we'll take that hit and we'll be fine. If it turns out that we don't like the unpredictability of that hit, we could just right here sweep through the whole thing, reading values and writing to it arbitrarily or something like that. But we don't really need to do that yet. So anyway, that basically gives us everything we needed. And now, you know, not to be anticlimactic, but you have now seen probably all of the allocations we're ever going to do. That was it. Maybe we'll chunk those up a little bit more. We may also do a thing for debug allocation where we do some stuff that doesn't quite work that way. But I mean, that's really what we're talking about here. That is really that's it. And so we know that basically if we get here, we're ready. The game will run. It will never fail. It will never run out of memory. Like the operating system has to fail at that point, not us. So we're good. So that's kind of cool. And basically what we're going to do from now on is we're always just going to use stuff in there. So I know it's a little anticlimactic. Like I said, very anticlimactic. But the basic reason is that everything, all the other systems we're going to do, the other interesting memory allocation stuff that we're going to do is all just going to be part of the systems that we write. So there's really nothing to cover other than what we just did. That was it. We now have memory for our game. We have all the memory we're ever going to need for our game. We are going to run the entire game in that memory. And so, yeah, party time. So I think that's basically all we needed to do. Let me double check to make sure that we actually show that we have gotten that memory and we have what we think we have, just to make sure there's nothing weird going on here. There we are. There's our 4 gigabytes, just like we thought. So it looks pretty good, and that is it. That is really all there is to it. That's all. So that is basically it. What we want to do eventually, like I said, when we start to play around with this a little bit more, we're going to want different profiles here, because basically what we're going to want to do is say, okay, on 32-bit platforms, we're going to allocate like 1 gigabyte of transient. And we might also take a look at how much memory is in the machine. We might allocate 8 gigabytes if the user's got a ton of memory, because you can always use more backing store to make the game more performant and stuff like that. So we'll see. So basically, this is basically what's going to happen. But you know, we'll fine tune how much we allocate and how a little more in the future. Of course, the other thing that we can do is just do these two as one allocation. If you wanted to pool them together, you'd just make this pointer point to, you'd add the two sizes together, and then you'd make this point a little further up. We could totally do that, right? We could totally just do that ourselves, but I'm going to leave them as separate pages for now, just in case one of them overwrites their boundaries. We had a better chance of catching that. We may do memprotects on either side of them in the future to actually guarantee we catch that sort of thing. Alrighty, that was 40 minutes for 2 virtual outs, because I had to basically explain things, but really that was it. That's the memory management. So what I wanted to do...
I will probably do it a bit later, because I don't understand yet the point of it. I understand game memory, but transient storage, and I'm not sure, so I can do it later.
The other things I wanted to do today, well, so maybe now is a good time. I don't know if we should really dive into keyboard input today. So what I think I'd rather do is I'd rather spend a little bit of time talking about something that I would want to do in this particular circumstance, which is I'd like to start having the ability to assert things. Basically, what an assert is a thing that you can put in your code that's just for debugging purposes, that lets you know whether or not something worked that you assume will always work, if that makes sense. And so what I want to do is I basically want to define, in handmade.cpp, I want to define an assertion function that basically takes something, it takes an expression, and then it is going to assert that if that expression is or is not true, basically if it's false, we want to halt the program. So we want to do something, let's say, like this. We want to do something where we go, okay, if expression, right, is not true, so the expression is not true, then I'm just going to like write to 0 or something, right? Something like this. I don't know. Just making this up as I go along here. So basically, what I'm going to do now is I'm going to come in here, and this is the thing I wanted to do before. I wanted to say, all right, I have a requirement here, and that requirement is that the game state structure, right, has to fit, obviously, inside the permanent storage size, right? Right? That's just a kind of a given. So I just wanted to say that. That was something I just wanted to point out to the program at this point. And so what I'm doing is I'm putting in an expression that we would normally if on, but I don't actually need to do anything based on it. I'm just trying to tell you this has to be true. I expect this to be true. If it's not true, I want you to stop the program immediately so I can find out why not. Does that make sense? So basically, like if I run this, nothing happens, which is what I expect. But if for some reason, right, we were in the Win32 handmade stuff here, I went in and I just you know, I was just being dumb, and I made this be 1 byte long or something like this, right? Then when I came through here, I would get a break, right on this assertion that just tells me, hey, you know, you said this was supposed to be true and it's false, right? And so what I did is I just made it a macro, right, that I can drop in there, my assertion macro. And the macro just says, hey, if the expression, I don't even know why I put it on a separate line. If the expression that you passed into it for some reason isn't true, just flat out write to the null pointer. Just write straight to null, because you know if you write to the null pointer, you're going to crash the code. So crash it. Boom, it's done. Why do I do that? Because that was the quickest way to do it platform independent. And I just wanted to put that up there. Why not? Now, you've got other options. Here's one of them. You can just, if you want to, have a platform independent way of doing a debug break. And that would be this guy. And that is just basically going to do a thing that launches the debugger, all that kind of stuff. But I don't really care about that too much right now. So all I did is I just needed something that would stop the program, and that will stop the program. So I like that because that basically, I like using asserts because it basically allows me to put stuff in my code that in general should always be validated, so that I know that I didn't miss something. In case like I change something later on and you know, and don't realize the consequences that change has, those asserts might catch it for me and save me some work. So I like that. I like to put that in there. It's a good thing. Now, what you may be wondering is, Don't they incur a performance penalty? And the answer is yes, they do. So usually what we do is we do something like this. We typically decide that we have something called a debug build, right? And we say that if you have a debug, if you're in a debugging scenario, then you will, actually expand it to something. But if you're not in a debug scenario, then you'll just make it expand to nothing. So there's no cost to doing this if you're not debugging. Now this brings up something which we've been dancing around, which is right now we just have a straightforward build that doesn't do any, there's no differentiation, but there's no way to switch different things. We have the handmade Win32, but that's about all we've got, right? So what we want to do now is basically define a couple pound defines like this debug thing that basically allow us to toggle certain aspects of our code. And so basically, I typically like to have, debug is kind of, I find that debug or not debug is just too ambiguous. It's like, what does that really mean? Like, do I want debugging code, or does it mean that I'm debugging? I don't really know. So I tend to like to have some other sorts of things that make a little more sense as to what you're doing. Like, do you care about whether performance is happening right now or not, kinds of things. Do you care about whether size is happening now or not, those sorts of things. So I tend to like stuff like, is this a build that's going to be released publicly or not? That's like one thing. Like, is it only running on my machine? So things like specifying the base address that we're going to do in a second here, that's like one thing that might happen only in debug. Things like, trying to think of what the other things are. Like, so internal build or external build would be one of them. Whether or not I'm testing performance right now or not, those sorts of things. And so basically, if I'm testing performance, I need asserts to go
Hey Tadas, long time no see.
away, right? So basically, I would like to do handmade performance, right? So basically, if let's say, or maybe speed. Let's call it handmade speed. Is it a speed build or not a speed build? How about slow? Let's call it slow. That works for me. So if we have defined slow, we can do our assertions. If we haven't defined slow, we can't.
Oh yeah,
right?
I forgot you.
So I'm going to say that we're building in slow mode now, and that's going to be fine, right? And that works for me. And then we're going to have the other one, which is handmade internal, and that's going to be defined to 1 as well. So then what I'm going to do is basically say, what we can also do here? We can even say by default what we would build, although, that's good enough for me. But what I will do here is I'll put these in here. I'll basically say handmade internal is basically 0 means a build for public release. 1 is build for developer only, right? And then we're going to have handmade slow. That is 0, no slow code allowed, and 1 is slow code welcome. So that's what I'm going to do. So if handmade slow is defined, we got assertions. If not, then we're not. And then I'm going to go ahead and say that internal build, I'm going to turn right around and use it in the place that I wanted to, which is down here. We're basically going to say if this is a handmade internal build, then we're going to try and set our base addresses, and if not, then not. Does that make sense? So I'm going to say that we've basically got, what does virtualAlloc want there? What does virtualAlloc want as that first parameter for an LP address? virtualAlloc, why don't you tell me? An LP void. So we're going to have an LP void. We're going to have an LP void base address. And that base address is basically going to be 0 when we don't have an internal build. Or it's going to be some magical value that we hope we can get when we have an external build. Now, if I remember correctly, and I probably don't, but if I remember correctly, in x64, on Windows 64-bit, the first 8 terabytes of address space are reserved for the application. So basically, if I wanted to, I could do something like say that, I don't know, this thing gets one more guy, which is terabytes, right? And that's gigabytes times 1024, and I basically say that the base address, it's at 1 terabyte, or 2 terabytes. Who cares? And of course, we got to do our cast again. Probably with terabytes, we could just flat out say that you needed to cast it in here, but yeah, yeah, I don't know. It's so hard to tell sometimes. Because see, the thing is, if I make it 64-bit, then it always has to be done in 64-bit, even if you knew that it didn't need to be done in 64-bit. I don't know. I don't know. Ladies and gentlemen, I do not know. Should these always use 64-bit? Question mark. It has that tonal rise at the end that tells you that you don't know what you're coding. You're just flat out making stuff up as you go along, and ladies and gentlemen, that is a lot about what coding is. So I'm going to basically say we're going to pool these guys, first of all. I'm going to do it like this, and that way we just have one base address, and we always try to get that base address. I'm going to say that we basically put the permanent storage first. Why not? I don't see any reason why not. So I'm going to say we want to take the total size. So let's say that we've got that value. We've got total size, and total size is just equal to the permanent size plus the transient size. Should be fine. I don't see any reason why it wouldn't be fine. And then I will allocate total size. After we are done allocating total size, I will assign the transient storage to just be the permanent storage, basically bumped up by the permanent storage size. There we go. So I'm going to do it that way. I said I wasn't going to, but I wanted to anyway, just so I can get that base address in there. All right, so there we go. So that, in theory, should do it. I allocate the total size, ask for the base address, then I go ahead and make the transient storage be where the permanent storage is, plus the permanent storage size. Seems pretty good. Seems pretty good. Okay. Yeah. Let's take a look at that virtual alloc. So here we go. We come in here. What's our total size? Make sure that this is a nice big old number. Yes, it is. We're going to allocate that. Did we get it? We did get it. And what does that number come out to be? That looks about right. 64 megs across. Where's there? Well, great. Can't. Yeah. Of course, it doesn't want to display that. I wanted you to display it in decimal. You didn't do it. I don't know why you didn't do it. I could force it to, but I don't really want to. All right. So off we go. And let's take a look here at whether game memory actually gave us the address that we actually asked for. So we asked for base address, right? That's what we asked for. What? What's going on here? Oh, great. So does that mean we actually have to force it to be inside the other thing because we didn't coerce it in time, basically? Fantastic, ladies and gentlemen. So I guess that answers our question. We're basically going to have to force this to do it this way, I assume. I don't actually know if that's a good way or not. But it answers our question, I guess, unless I'm wrong about what's going on there. Let's take a look. Let's take a look. What? Still wrong. I don't know what's going on. What am I doing? Oh! Do I have, yeah, that's great. I flipped the cases. That's dumb. So I never assume you know what the problem is, really. That's the thing. You think something's trivial, that you know what the problem is, but you don't, right? You just pretend you know what the problem is. So the problem was actually that I had this case reversed. So it was always initializing to 0 instead of my terabytes value. So I didn't actually need to do this. At least I don't think I did. There we go. Oops. Cannot convert to LP void. That is fine because we're just going to cast that. There we go. Let's take a look now if I actually got my base address. There we go. That's what I wanted. So does virtual alloc succeed? Oops. Awesome. The perils of undo as well. Boy, this is just not going my way here these last few minutes. It was going so well there, and then I kind of spazzed out on you. I apologize for that. I don't know why. I wrote the code right the first time. At least, well, I assume we wrote it right. Maybe it was wrong the first time as well. And then we can feel better about ourselves for being wrong, I guess. Let's see here. Okay, I'm going to add the permanent storage size in there. Cast this to a byte pointer so that we are advancing by bytes. Add the number of bytes that the permanent storage takes up, which gives me the rest. That should do it there. There we go. And let's take a look. See what we got. All right. So the transient storage size, the permanent storage size, both set properly. The total size looks right. Base address looks right. Let's see if we got our permanent storage. We did. It's at the location we want. Even better. Is the transient storage up above where it should be? Yes, it is. Everything is coming up roses now, ladies and gentlemen.
No. No, it's what's it called? It's just a video, not a stream.
It is beautiful. All right. So that's all well and good. That looks fantastic. I don't see anything wrong with that. I think we're all good. I think that was everything that I wanted to do today, even except keyboard, which I guess we'll save for tomorrow. But that is it. That is all there is. We can now have a full-on party. I'm trying to think of if there's anything else we need to do here. But really, we are getting down to the last of it, ladies and gentlemen. We are getting down to the last of it. There is not a lot left that we have to do. Now, one of the interesting...
I still don't know what permanent memory was.
things here
Probably go
is
back.
the Win32 resize div section guy. This is pretty interesting. We could actually pool that allocation as well. We could actually just have one alloc. I don't know that we really need to do that, but we could. That's all I'm saying. Like I said, I think I'm out. I'm out of stuff. I would have to start on something totally new. We may go to the Q&A early. That's how well that went. That's how well that went.
And I'm just gonna go back and see what the actual type was.
Pass it. So
Think around here.
chunk of memory at the beginning. We pre-decide how much space we're going to allow each thing to use, each subsystem to use, and then those subsystems are going to be written such that they must run in that space. So it is not a question of memory allocation down the road. So why am I saying now is the time? Why talking about allocating like a gigabyte of memory to store stuff? It got allocated properly. It would fill out some stuff in the game state, so it would do. I like to do is things. There's all sorts of was we needed a sound button throughout the entire stream. Crazy town, right? Memory allocation is just a willy-nilly thing these days. Fortunately, these days, fun again for people who really like to. So it is not a. I say on a lot of streams, I'm just telling you how it's working while we were sort of playing around defining our platform API.
Yeah. I missed it again. Maybe does it define it early on?
This is actually
Yeah, that was the C++ stuff. Excuse me. That was the asset stuff. Keep going. Let's see, define. Right, that's what I need. Yeah, that's. Am I missing something? What is permanent storage? What star does it mean? Does it just mean bytes? Yeah. No, it would be. Damn, can't read C sometimes. What does void star mean in C? It's a untyped pointer. Here, does it mean void type permanent storage? That's what I understand. I am not really sure. Maybe I can look into. Well, my guess is it's a slice of bytes. They are back. Create a dashboard. Permanent storage size. That's my guess. Though I'm not exactly sure. Maybe I should just go back and watch it. Not all of it, maybe.
like this, right? And then from then on, it would basically that they aren't going to fail because either some story, sometimes the story and the platform, where the platform just says, I propose if I don't think this is a good idea. Well, what I and we'll be also seeing that I will take the same tack with Disk.io, which I realize is a little odd, but I'll be taking the same track with Disk.io. So the goal here is like there's 0 failure states in the game. Is transient, and then permanent stuff. So basically, stuff that stores the actual state of the game, such that it definitely needs to persist as is from one frame to the next, because it's what holds sort of the game together, right? And so basically, what'll happen here is I want to be able to store these things: the blue offset, the tone hertz, the green offset. Those are examples, right, of things that need to be stored in the permanent store. And so that's really all I have right now. And so basically what I've got is I've got an I guess I'm going to use an N64 here in case we ever want to be absolutely giant. So I'm going to say we have a UN64, which is essentially our permanent storage space, and then we've got a void star, which is our permanent storage, right? So all I'm doing here is I'm basically saying, well, I'm going to have some place to store. Wow, I'm a spelling genius tonight. Basically,
Okay, so that's what it's for. I'm not sure how to save.
I'm going to have some place to store things that have to persist from frame to frame, because that's what I want here. So all I'm going to do is I'm going to basically say, well, that game state thing that I had, right, that I'd defined before. Oh, did I just go ahead and delete that? I'm an idiot. That's not good at all. I wanted to keep that. I just wanted to move it. I didn't want to delete it. There we go. So anyway, let's get that back there. Game memory. Memory. There we are. So basically what I want to do is I'm going to take this game state.
What is memory? Oh, that's the name. Oh, fuck. Always get confused. Type comes first. Let's see. Okay, that's why. Okay, now I understand.
Here, right? And I'm just going to put that inside the game memory. Now I can put that here. I don't know if this doesn't really need to be in the stuff that defines the platform. So I'm just going to separate that out for now. We'll see where I want to live later, because this is not something that the Win32 layer needs to know about. So I'll think about it a little differently. But point being, this guy is going to come in here, and basically all I'm going to do is I'm going to say that my game state, right, whatever this game state is, that's just going to equal, for now, I'm just going to go ahead and cold cast straight to the actual memory that I've got for my permanent store, right? My permanent store.
Interesting. So I do need const game state. I think at the moment I've only got on Earth, which is a float. 32. If I understand correctly, game state's gonna be stored inside permanent storage. Yeah, I'm not sure how that really works. Because this needs to be visible in the platform. Yeah, not sure. Basically, game state is stored here. Oh, this is a different struct. This is stretching my understanding of programming. I mean, I get the idea, but it's not something I've done before at all. Well, let's give it a go. This audio doesn't need it. I'll just do it here. It's much easier. Made dot game state goals undefined for now. Game memory. It's also undefined. Actually, I could just allocate this. Storage size. How much was it? 4 megabytes. Kilobyte KB is 1024. I can't use the arena because it gets cleared at some point. Let me try fix buffer. And I need a buffer. I mean, in that case, why not just use the array? I think this should be done before. Move this up here. Funded dot heap dot fixed buffer allocator. Okay. What do I do with it? Guns and allocate. What if I just create type equal to allocator dot needs the type made game state. Catch unreachable. Is that the same thing? Kinda. It means I really don't need this. That I can call this game memory. What would this be? 4 MB. I mean, it seems kind of similar. I mean, in fact, I could just do plus, was it 2 GB? No. And then, where's my game update and render? This would need game state to be pointed to game state. That means I don't need the sound buffer here. And build sound buffer. Delete that. Okay. Dot tone hertz equals 256. I'm not sure if it's the same thing, but kind of I mean, it looks kind of similar. Where's game? Variable of type must be const to com time. Mm. And can it be const? No field named tone volume. Oh fuck, I think it deleted the wrong one. Main 42. Yeah, this is no longer needed. Handle key press event. And made 109. Okay, it doesn't need the sound buffer anymore. That's pretty cool. Okay. Still works. Still gotta do the move, what's it called? Audio to a separate thread. And while I'm at it, I can add the offset. And I can make it animate as well. But what I still don't understand is the transient memory. So I think my best understanding was this is permanent. Permanent memory. It's about 0 to 64 MB. And then the rest. 2 GB was transient. T- 2 GB. Yeah, and the game state should be in the permanent memory. I think this might not work. Yep, I thought so. Let's have a look at memory. Using an allocator. Yeah, but I don't think it allows 2 GB. Yeah. Not sure about this yet. Might have to look into it. What was it called? Virtual. Actually, make it as entire pages of memory. Asking an OS for memory requires a system call. It's also extremely inefficient for speed. To a fixed buffer and does not make any heap allocations. Probably why it doesn't work. Yeah, I also don't think. Okay, it doesn't need to be freed either. Buffer allocator. Yep. I am not sure. I mean, I can't use Arena at currently because where is reset? Yeah, because of this resize. Because if I resize the window currently, it will, what's it called? Will reset the game state as well. Probably have to get rid of this first. Not sure. Figure it out later. I have to continue from here tomorrow. Kinda stumped. Can I get memory ahead of time? I mean, what if I just allocated game state? Whatever size it may be. Maybe I can just reset part of it. Okay, maybe I could just resize it. Takes a pointer, memory, alignment, new length, return address. Okay, that could work. And then I don't need to do this. Was it allocated or resize? Set display buffer instead. Resize instead of reset. Oh. Okay, for now that works, but it's not really correct. This will not work when adding. Okay, I'll think about it tomorrow. I don't need to save that. I'm gonna call it a day there. The sun's out a bit early. Alright, I'll be back here tomorrow. I hope you have a good day. And I guess see you for now. Bye.